Okay, so we're gonna be talking about four topics. Gonna be work modes and source priorities, off-grid system with generator input, system with AC couple and solution. Last but at least, question and answer. Is everybody I know most users use
Jeez, it's almost be
self-consumption.
better in Spanish. This guy is.
So I believe most common work modes are self-consumption mode and power backup, and there are also a charge first mode and system without PV installation, which basically is the same as the power backup with battery. Okay, self-consumption mode is will use solar, then battery, and the last is utility. So the
Son of a
inverter
bitch.
will use the solar power to cover
Hmm.
the consumption mode,
Damn it.
and if the solar is not sufficient to cover the load, the battery will discharge power to compensate the insufficient part. But if both solar and battery are not sufficient, the grid will take over the compensate the insufficient part. Configuration via app or web. So you have to set the AC charge, charge first PV, force discharge, PV cell, and peak shaving must be disabled. And then you have to set your on-grid cutoff SOC or volt to where the battery discharge. It cannot be discharged so so the utility can provide the power to the load instead of the battery. But just make sure the off-grid cutoff SOC is lower than the on-grid cutoff. Configuration via LCD panel on the inverter itself. Set the AC charge disable, charge first PB, force discharge, and peak shaving disable. Same thing, you set the on-grid cutoff to a certain SOC where you desire when you stop discharging your battery so the utility can provide the power to the load. Same thing, off-grid cutoff. Just make sure you set the off-grid cutoff lower than the on-grid cutoff's SOC. On the bottom, once the battery SOC or volt hits the on-grid cutoff SOC or volt limitation, the value to return discharging is on-grid cutoff SOC volt plus 5 or plus 2 volts. Once the battery SOC volt hits the off-grid cutoff SOC volt limitation, the and there's a grid power, the inverter will charge the battery from the grid to off-grid cutoff SOC plus 3% or plus 2 volts with 5% power, rated power AC charge. To avoid charging from the grid, please ensure that the off-grid cutoff SOC is lower than the on-grid cutoff discharge SOC or volt. Charge first mode, solar, utility, battery. During the daytime, use solar power to charge the battery first. When solar power is insufficient, the surplus part could be used to compensate the load. When the nighttime battery discharges to compensate the load. To set via app or web, set the charge PV enable, set the charge, the AC charge, force discharge, PV cell, peak shaving disabled. Set the charge first power to default or desired value. Set the stop charge first SOC or volt or default or the desired value. Set the charge first time 6 to 18 or the desired time slot. On-grid cutoff SOC volt. You must set this as same as the set on-grid cutoff to the exact value. Again, off-grid cutoff SOC always lower than the on-grid cutoff. Configuration via LCD panel. Set the charge first PV enable. Set the AC charge, force discharge, and peak shaving disabled. Uh, Basically, it's the same thing as what you said on the for the app and the web. But on the bottom, within the charge first time period, the inverter won't discharge the battery power. So if you don't want to use the battery power when the grid is on, you could set the charge first enable with a certain time setting. During the charge first time period, the battery gets charged to set the value. The inverter uses PV power to compensate the load consumption first. Utility, solar, battery, or power backup mode. Battery will discharge exclusively during grid power outage. Use solar power to charge the battery first and use the grid to take the loads. When solar power is sufficient, the surplus could be used to compensate the load. When the grid is power when the grid when there is a grid power outage issue, battery discharge to compensate the load. Configuration via app or web. Charge first PV enable. Force discharge PV saw peak shaving disabled. Set first the charge first power to default or your desired value. Set the stop charge first SOC or volt 100% or the desired voltage. Set the charge first time to 00 to 23:59 and only use uh, one time slot. Set AC charge enable according to the time SOC and volt if PV power is insufficient. Once hitting this value, set off-grid cutoff SOC volt. Once hitting this value, the battery stop discharging. Again, off-grid cutoff always lower than the on-grid cutoff. Configuration by LCD. Set the charge first PV enable, force discharge, and peak shaving disable. Set the charge first power to default or the desired value. Set the stop charge first SOC or volt to 100% or the desired voltage. Charge first times 100-2359, same thing as the last one. So once hitting the off-grid cutoff SOC volt, the value return discharge is off-grid cutoff plus 5% SOC or 2 volt utility and battery. System without PV installation. Battery will discharge exclusively during grid power outage. When the grid is on, use grid power to take the load and charge the battery at the same time. When there is a grid power outage issue, battery discharge to compensate the load. Configuration via app and web. Set the AC charge enable, disable, force discharge, and peak shaving. Set AC charge power to default or your desired value. Set the stop AC charge SOC or volt 100% or the desired voltage. Set the AC charge time 1 00 to 23:59. Set off-grid cutoff SOC or volt. Once hitting this value, battery stop discharging. Again, off-grid cutoff must be lower than the on-grid cutoff. Off-grid system with generator input. We're gonna talk about generator remote control, generator control with microgrid function enabled, generator remote control. Implement automatic start stops using dry contact control condition. The generator itself has an automatic stop function. I guess I believe everybody should know how to connect the connection to the inverter. To set them up, configure the automatic stop in the monitoring platform by setting the start and endpoint battery SOC or voltage. Just make sure you put the generator rated power. I usually tell everybody to um if the generator is 20 kilowatts, I always tell them to put like 18 lower than the rated one. So it prevent the generator from overloading. It is recommended that the generator capacity is equal or greater than the inverter capacity. Battery off-grid cutoff SOC or battery charge request could also activated the dry contact to start the generator. Generator with microgrid function enable. You only use this microgrid function if the generator is connected to the grid input of the inverters. Set the microgrid function to enable so the inverter knows the generator installation is at the grid port. And also it tells the inverter the generator setting will be used instead of the AC charge to charge the battery. So we have a new feature. They call it a generator boost, which enable the inverter to work mode to take the load with solar and generator together. If the generator is um, lower capacity than the inverter itself, for example, if the generator is only 6 kilowatts and the load is 12 kilowatts, the inverter will supply at the rest of the 6 kilowatts. It's either from the PV, solar, or the battery. If it's if it's an off-grid system, the microgrid function will support battery wake up function when the battery goes to sleep. If the capacity of the generator is not big enough and the load consumption is heavy, generator boost function could be turned on. But you must have I believe 18 and 18 firmware and up to use the generator boost function. System with AC couple. AC couple connection, priority sequence with AC coupling input. AC coupling input need to be connected to the gen port and ensure that the generator is not connected to the gen port before enabling the AC couple function. The current limitation of the gen input relay is 90 amp max. So ensure that the max input power not more than 90 amp times 240 volts or equal 21.6 kilowatt at 240 volt. Priority with AC couple input. When there is a grid input, you just need to set the AC couple grid cell back and able to let the existed PV inverter to work. So you enable this and this. When there is a grid power outage or no grid power input, to let the AC couple work, you need to set the AC couple enable and also AC couple start SOC or bolt or AC couple stop SOC bolt. Tips. AC couple frequency shifting control. When the battery is reaching charge and SOC bolt or AC coupling input power is higher than the total amount of charging power and the load consumption, the inverter will increase the output frequency to force the grid-tie inverter into over-frequency power response mode. Remember to enable over-frequency power response mode from the grid-tie inverter and priority sequence with AC coupled input. AC coupling input will be viewed as a PV power to control. So the priority sequence when working with self-consumption mode, the charge first mode is the same as the integrated PV power. Use AC coupled power for load consumption when AC coupled power is insufficient to cover the load consumption, the battery discharge power to compensate the insufficient part. When both AC couple and battery are not sufficient, the grid will take over and compensate the insufficient part. Self-consumption mode configuration via app and web. Set AC couple enable. Set AC charge first PB, force discharge, PV cell, and peak shaving disabled. Set the grid cell back enable. Set ungrid cutoff, SOC or volt default, or set it to the exact value when the battery discharges below the value. The battery will stop discharging and the utility will provide energy to ensure continuous electricity supply. Again, when setting the off-grid cutoff SOC volt, always lower than the on-grid cutoff. Priority sequence with AC coupling input. During the day time, use AC coupling power to charge the battery first. When AC coupling power is sufficient, the surplus part could be used to compensate the load. During the night, the battery discharge to compensates the load. Set AC couple enable. Set AC charge first PV, force discharge, PV cell, and peak shaving disabled. Set grid cell back enable. Set charge first power default or the desired value. Set the charge first SOC volt or the desired value. Set the charge first time 6 to 8, 6 to 18 or the desired time slot. Priority sequence with AC coupled input. Battery will discharge exclusively during grid power outage. Use AC coupling power to charge the battery first. Use grid power to take the load. When AC coupling power is sufficient, the surplus part could be used to compensate the load. When there is a grid power outage issue, battery discharges to compensate the load. Draw from the AC coupling first. Set the AC couple enable. Set charge first, AC charge, force discharge, PV cell, peak shaving to disable. Set the grid cell back enable. Set the charge first power to default or the desired value. Set the stop charge first SOC volt to 100% or the desired voltage. Set the charge first time 100 to 2359, and then set the on-grid cutoff to default or set it to an exact value. Set the off-grid cutoff SOC volt. Off-grid cutoff SOC volt lower than the on-grid cutoff SOC. Set the AC couple start SOC or volt. Set the AC couple stop SOC volt, and then set the over frequency power response mode enable from the grid tie end. So the set AC couple start SOC or volt. This is when the AC couple will turn off. I mean, no, when it will turn back again. The AC couple stop SOC is when the battery is full. It will cut off the gen port. Okay. I'm sorry. This is my first time. This is my first time too doing a presentation on the Zoom, and I'm sorry if you didn't understand me. If you have any question, you can ask now. Do you guys have any question?
Hi,
There's a
Gilbert.
couple of questions in the
Good.
chat.
Yeah, a couple questions on the chat.
Okay.
Actually, let's see.
Like one, can you AC couple without the grid? And what are some maybe guidelines with AC coupling with different inverters and microinverters?
I believe most of the grid tie inverter works with our inverter with the LuxPower inverters. As long it should be safe if you connect to the gen port.
And does it need to be tied to the grid to use AC
No,
coupling? Okay, nice.
Yeah, you can either with or without grid. You can use the AC couple.
And sorry, another question. When would you suggest using the microgrid function versus the generator port?
So if your generator is connected to the generator, you don't have to use the microgrid function. You only need it if your generator is connected to the grid input. This will tell this will tell you the inverter. I mean, this will you're just letting know the inverter that the generator is on the grid input. This also prevent backfeeding to the generator when you enable the microgrid.
Awesome, thank you.
You're welcome.
A question about that microgrid option. Is it better to use it on the microgrid function or best to put it on the generator function?
You're asking for the generator?
Yes, for the generator, which option is better? And on the generator input side or the grid input side?
It should work the same. but it should work the same because when you use either way, you still be using the generator setting. That's why. But um, but in my experience using the grid input, it has a faster transfer switch than the generator port.
Okay, thanks.
You're welcome.
Got another question here in the chat. It says from Bill, if the generator is continuous duty 40 kilowatts, what should you enter for each of 3 parallel inverters?
So it because so right now we have the generator boost. You can either uh you can put it on the master 40 kilowatts, or like I said, I always put lower than the capacity.
So do we divide the kilowatts per between each inverters or just put it on the one
Just,
on the master inverter only?
just the master only. Any parallel system, you always deal with the master.
All right, so question. Just the next question about the parallel thing. If I have two inverter parallel, right, and I have a 30 kilowatt hour battery bank, right, and the recommended amperage to the batteries would have be 150 amps, right? Should I split that 150 amps between the inverters or just put that 150 amps into the master inverter in
So
terms
if
of the
you're not
battery charge amperage?
so if you're not if the inverter is not communicating with the battery, then
Yeah,
yeah, you should divide it to the inverters so you don't
but if it- but if it is
overcharge or discharge.
but if it's communicated, you can just put the 150 into the master.
If they're communicated, it should be automatic.
Okay, but it still asks for the battery charge amperage settings. So what would I put in the sleeve inverter? 0 or
So
the same
so
150?
so if you're already communicating with if the battery and the inverter is communicating, it's
Yes.
automatic. It's automatic. You don't have to set anything.
Okay, fine. Another question though, with the 6K Lux Power inverter, can these inverter use without battery and also do a zero export?
Um, the 6K,
Yes, the
yes,
6K Lux Power.
yes, it will work
So
without battery.
So
You,
what if I don't want to sell back to the grid, but I just want to sell to the existing loads in the panel? Can it work without battery? So
it's yeah,
example,
because
I don't have a contract with the grid to sell back power to the grid, but I just want to offset the loads that are connected into
yes,
that grid panel.
you can do
So
that.
that and I still have to use the CTs.
You don't have yeah, you don't have to use the Siri. Just don't enable the grid cell on the 6K.
Do I enable the what? Can you repeat
Um,
that? The grid cell?
yeah, the export to the grid. Keep it disabled.
Which is the fast zero export. Keep it enabled
No, you keep it zero. The export to the grid.
or zero. So even though
This,
it even
disable it.
okay, so even though it is connected into the same grid panel, wouldn't it export to the utility?
No, because the inverter will regulate the PV input just to cover your load.
Right, but what if the load is not much? It won't exceed the amount from the panel.
No, either it will turn off your panel or
Yes.
just it will turn down the PV input power.
Okay, so you're saying that if the load is 100 watt, it only take 100 watt from the panel.
I'm sorry, say it again.
I'm saying that if the grid panel is only pulling 100 watts, it will only take 100 watts from the panel.
Yes.
Interested. I just say I don't have to use any CT.
You don't have with or without CD, you shouldn't. You only use CD with
Yes.
the 6K if you wanna backfeed a panel, just like the
Like
12K.
explain what I mean by backfeeder panel.
So if you have a critical load and
Yes.
uncritical loads,
Yes.
so either you can if so if there's a still if there's a grade,
Yes.
you can backfeed the uncritical load.
Or you can sell back power onto the non-critical panel.
Yes.
Okay, but let's say once the 6K, once that turn off battery function, it will work it will work just the same. Once that turn off no battery function, connect the grid input to the inverter input, it will only produce what the panel needed.
Yes.
All right,
It
thanks.
the inverter will only produce what is the consumption reading.
Okay. Can the 12K CT works with the 6K CT? Is it the same CT?
No.
Okay.
The 6K use the 100 amp, I believe so. 100 amp and 100 milliamp uh ratio, I think.
Okay.
The 12K CT is 3-to-1 ratio. The 6K is 1-to-1, I think. 1-to-1, yeah, 1-to-1, 1-to-1,000, I think.
Okay. Sounds good.
So to clarify, this presentation was for the 8K, 10K, and 12K, and then some of the settings are a little bit different for the 6K. We have another question in the group chat that says, on gen input limit of 90 amps, is that additive with parallel inverters, such that if we had a larger generator of, say, 150 amps, could I install a sub panel for the gen to feed and install 75 amp breakers to send 75 amps to each inverter? You see that in the chat from Travis in the chat box.
Let-
And then there's another one from Matt after that.
So you're saying if you have multiple inverters and you wanna, okay, let me read.
Could you ask? Yeah, could you ask that again? It kind of cut out a bit.
Let me read the question.
I think he's wanting to know if you could bypass the 90 amps if you have a generator that's rated for more than that.
Maybe you want to split the amperage between the both inverters rather than just put in the 1 amperage on one inverter.
1 second, hold on. So we're talking how many inverter are these? Travis? You said what on gen input limit to 90 amp, is that additive with parallel inverters? So if you have 2 inverters, that's gonna be 180. So you just added. One inverter is limited to 90 amp. Did I answer the question? So if you're saying you have 3 inverters, so 3 times 90, that will be your input for the generator.
I think he's on mute or
I'm sorry?
maybe he's on mute. Couldn't hear any response.
they can unmute if they.
He's saying his mic isn't working, and he's putting his response in the chat box.
He said he understand.
Okay, Gilbert, I think you can leave your email address on the chat. Also, somebody may contact you for more questions.
So there's another question from Bill saying back to the AC coupling in off-grid mode. If the 18K adjusts to the frequency to the gen port to adjust the output of the AC coupled inverters, does this also adjust the frequency on the load output terminals?
Yes. So the AC input, I mean the generator port, and then the load will be at the same, because the load output is that's gonna be the microgrid thingy, so it will keep it on. So the gen port and the load output will be the same frequency.
Looks like you have another question from Bill and Alpha Nova Solar in the chat box.
Okay, back to the AC coupling. So back to the AC coupling. If the is it about the frequencies shifting?
No, it's saying, is it okay to use 312K/10K US unit to feed each individual phase in a three-phase Delta 240 system using the grid port?
I believe our inverter doesn't support delta 3-phase. We only support the Y type 12208.
Yes, he's here. They can just speak.
Yeah. So yeah, I just posted the question. What I'm really asking is, so each phase is 240 volts. So it's not that we want the inverter to be synced with the three phase, just the single phase, just one phase.
Or you want
So,
to use a 220 single phase. So it's a three-phase 440 system.
each inverter would only be seeing one phase.
So basically, your billing is a three-phase 440.
No, it's not the 440. It's 240. So it's the same. It's the Delta system, but I'm just checking if it's okay to configure the inverter maybe in the using maybe the UK standard, and then allow it to only see one phase. So you're not configuring it for three phase. It's still single phase, and you're assigning each inverter in a sense to one of the phase.
So you're not gonna be using the line 1, line 2? You're not gonna be using 120?
No 120. Because you're only using the grid ports.
Or you
I
want to use
know
the grid type.
I know our inverter can do a single phase, like neutral and line for
Yeah.
220 to 240, I believe.
Yeah.
But we have to configure it.
Yeah,
We have to configure it for UK, I believe, specification.
Yeah.
But I believe what I was wondering, if you do it like that, each inverter is going to be running at different sine waves. So if you should pull a load across a three-phase, each inverter run at different sine waves, I don't think it will work properly because each inverter have a synchronized to know that when to move at each sine wave.
Yeah, but it's basically operating in
For itself.
in grid time mode. So we're not using the output.
You're just sending back power.
Yeah, you're just sending back power. So you're just syncing to each
phase.
So one inverter only has one phase to monitor and sync with.
Right. I understand what you're saying now. Can that work?
Well, we can configure it to a single piece.
Right, but what he's asking, if you use 3 inverter and 3 different phase as a grid time mode, will it work efficient and okay?
I believe the inverter will sync with the grid input. I think that's how it works with the grid inverters.
Yes, that's how it works. It will sync with the grid with the grid.
Yeah, yeah. So that's all I would do. You would have like, say that the breaker panel has, well, would go from, trying to see the connection. So in the breaker panel, you'd have probably,
So basically, I'm saying from neutral to line 1 is 240, from neutral to line 2 is 240, and from neutral to line 3 is also 240.
well, in the delta, it would be line to line.
Yeah, it would have been line to line.
Yeah,
Right,
but
that's I
from
was
the
asking.
endpoint, it would be neutral to line.
Right, that's I was asking if the billing is a 440 setup because it's neutral to neutral, it'll give you 240.
So the connection will be if you if we configure it to a single phase. So line 1 gonna be line 2 gonna
Yeah.
be the neutral. The neutral and the passbar will not be used.
Okay, yeah. So if I connect, so from the delta system, line to line is 240. So if I connect the line from the inverter and the neutral from the inverter to the line,
Line 2 gotta be if line 2 is the neutral. Line 1, but you have to let us first. We have to configure before you connecting it.
okay.
Can this be configured via the internet or with the LCD of the inverter?
Yeah, you have to. Yeah, we have to connect it remote. I mean, configure remotely.
So we can use the LCD of the inverter to do this, connect to
No,
do this. Okay.
no.
Okay, as in, I mean, Luxpower has to do it, or we can just log into the portal, to the online portal,
We have to do it.
or to configure to you. Okay.
Can can this inverter give out the 190 on 190? If we are doing 3 phase setup, a 3 phase parallel setup, can I get 190 out of it?
Um,
I doubt it because that would be delta.
Yeah, that be delta said way, but it depends on the type of delta.
I'm. All I know is we only work with the Y.
Oh, if it's the Y, then
120/208.
if it's the one is the 208, then that it wouldn't work then.
Yeah, it's only
I know
208.
Delta 8 doesn't work.
Yeah, I think once the inverter can see the 240 volt or 230, I think it should work because that's all it is going to see, and it will just synchronize with that leg.
Right.
I haven't tried it yet though. All right, that was my query.
All right. Thanks for this session. It was very informative.
You're welcome. Thank you too.
Yeah, welcome.
Any more question?
Yeah, I had a quick question regarding the 12K inverters. Looking at the specifications of it, it shows that it can handle up to 18K inputs, but I can only export 12K at a time to the grid, right? So I guess what I want to know is, am I able to take that remaining, say, 6K? Is it worth installing, say, a 20K like array at somebody's house, PV array, right? Can I export that remaining 6K to like batteries? You know what I mean?
Yes.
Because I don't want to put in such like a big system, right? If I can only export 12 at a time anyways, but I noticed in the specifications, right, that we can do up to 18. It says that it can handle 18 input. So I don't know how it functions, you know what I mean? I'm just wanting clarity on that. I can still use that to then say the remainder, if he's got an 18K system, oh, we'll send 12K out to the grid loads, whatever, and then the remaining 6K can be used to charge his batteries, right? And you're saying
That's
yes?
correct. That's correct.
Okay,
So yeah, actually it's up to 21. Yeah, you can put up to 21K, but it will only utilize 18K, 6 to the grid, and then 12 to the grid, and then 6 to the battery.
okay. Well, that was my question. Thank you. I have questions about some other hardware things, but that's not really the discussion for it, or forum for it. Like I have some customers complaining about the noise level of fans, and I don't know who I go to, for example. Like I don't want to void warranties and put in like lower
Is,
dB rated
is
fans.
are you guys
Um,
talking about the 12K?
yeah. So
The-
when they get winding up, we put them in a number of people's homes, right? Like in their garage. And I've had some customers recently that they can hear them inside their houses, like through the walls, because we put them in the garage and like say they have a kitchen nearby or whatever. And like sometimes on the larger systems, they get so loud because those fans end up running at like, you know, full bore. Like I got a guy with like, I think it's like 40 panels or something, you know, and
Right.
370-watt panels. He's got a huge system, and you know, when that thing is just humming, it is humming, and you can stand in his kitchen and hear it, right? And I don't know, like I've kind of reached out to, I think Preston's in here. I think that's the other guy that it sounded like him, anyways. But you know, I don't know who I can like go to, because like I'd like to find an alternative to like install, like, because I know there's lower dB rated fans and different things like that, but I also don't want to be voiding warranties, right? Like I need an approved, you know, ways, means, or process or something, because like I want to continue to work with you guys. We really like your products a lot, but it's like it's a snag that I'm running into with the number of customers in my area, right? Because a lot of them want them in the garage, but then they're like, yo, that's loud. And it's like, you know, so I've got this like, I love the product, you know what I mean? But yeah, I understand the customers end too. I mean, I don't know who I can reach out to work with on something like that, but that would be like another little piece of input I just have in general too, in regards to the 12K inverters. But I'm just throwing it out there since I have the floor for a second. But
Yeah.
um,
Actually, they working on it. The engineer is working on it. If they can lower, because right now anything below 6,000 is quiet. 6 kilowatts.
yeah, but I almost hardly install any that are smaller than that, right? Like almost everything that we install is bigger, which is also why we use your guys' inverters, right? Like because it can do up to such a larger wattage, right? And so, and you know, some of the other ones they only go up to like 7, 6, this, that, whatever. And we have a lot of customers who want a lot, you know, a lot of power. They want to cover their whole homes, whatever. They don't want a power bill. You know, we got a lot of higher end clientele and things like that, and you know, they got bigger homes. So I'm almost never installing a system under 6K. You know, is what I'm getting at.
Okay. Yeah.
Which is why we
They,
also like using your products, right? But
thank you. They working on it right now if they can try to lower the noise. But yeah, because they don't want to fight the inverter. That's why, because the inverter is big and it's built a lot of heat when
oh,
it's working hard.
no, and I understand. I mean, I'm, you know, I understand how it all works, and I know why the fans are running. I also know that there's like sometimes you can get lower, more silent rated, like decibel rating, like fans and stuff. And even if we could just work on like one that's okay or approved for me to install in there, should the customer say have an issue, even if you're not putting them in all of them, or you know what I mean, things of that nature. You know, there's just I don't know. It seems to be coming mostly from the ones that are located right in the rear on the bottom, not necessarily an interior fan or anything like that. The ones that are easily replaceable. That's kind of behind the controls right there up against the wall. That little strip of like 4 of them. But I don't know. I mean, I'm just looking for a solution because I don't want that to be the thing that like stops us from like, installing your product sometimes, right? That's kind of a silly reason. I love a lot of the features and functionalities, what I can do remotely. I think the product's great. I mean, my company is probably literally using it because I've been standing here vouching for you. And at the same time, I don't want to, you know what I mean? I don't want to have that ruined or like hung up based on, something so simple, like
Okay.
some noise. That's all. That's the only reason I bring it up.
Thank
for,
you. Yeah. I'll let the engineers know. Thank
Right.
you.
Uh-huh. Nope, then thank you. Also, I heard someone mention too, they would love to know if they could get a download of the presentation or the slides. I don't know if you had mentioned
Yeah.
or caught that
I can.
earlier.
Are you on the which? Are you on the
I am the WeChat. Yeah, I have joined
WeChat
that. Yes.
or
I think
WhatsApp
it's the
app?
WeChat. Yeah. Or was it the WhatsApp? I think it is the WhatsApp. Yeah, it's the WhatsApp.
I'll post it over. I'll post it now.
Yeah, just someone else in here was asking about it too, and I thought, yeah, I wouldn't mind just having anything for reference. I always love reference material. I mean,
Okay,
I knew.
I posted on the WhatsApp group chat.
Right, sweet. Thank you very much.
You're welcome.
I've got a question now. Can you hear me?
Yes.
Oh, good. I switched to my phone. This is Travis. I was typing earlier. On the setup for this solar utility battery mode, the charge first mode.
Okay.
It looks like there's some time value settings. Because my question is this: can you set it up to pull from battery just during certain times of the day versus always whenever the load is greater than the solar? Instead of doing it anytime it does that, have it do that only during certain times of the day. Because we have a couple of jurisdictions with time of use charges that are peak charges, and we want to reserve the battery to be going just during those times, not during the day when it's the low charges. And so we're like, oh, we only want it to discharge during 4 p.m. to 8 p.m. and also during so whatever the other time is, 7 a.m. to 10 a.m. or something. Can you set it for those specific times? Was not quite clear on the slides. I wasn't following if that was possible.
So the charge first PV you said, right? So I use this mode if I don't want to discharge my battery. Because the inverter default mode is self-consumption. So if
Right.
you set anything time on the charge PV, those time it will not discharge your battery.
Okay.
If PV is available, it will charge the battery first. And if the battery is full, it would cover the load after that. So anything you put on the time, it will not discharge your battery. So you have three time slots. So you can do in the morning and in the.
If you set time slots, the time slots are where it will not discharge the battery.
It will not discharge the battery.
Okay, so when I want a certain time slot for the battery to discharge, then I simply select the times I don't want it to discharge. That's what I put in. Then I'll get it discharging only during desired times.
Yes, because the inverter is self-consumption default.
Just default.
As long the
got
rest
it.
of so as long all the other mode is disabled and charge first is enabled, whatever the time you put it on, it will not discharge your battery. So you do the other way. So if you wanna, I hope you understand what I mean.
Yeah, I'm following you now. I just had to wrap my mind around it because other inverters that are similar to Lux I've used, they're the opposite. You tell them what times you want it to do that. But just with Lux, it's just the opposite. You just tell them the times you don't want it to do it.
Yeah, it's not in the manual. I just figured it out when I was playing with my own inverter.
Okay. All right. Great. I appreciate knowing that. That's good to know.
You're welcome.
Could you give us a little bit of the experiences using the gen boost function, or maybe talk more about that? Curious about the gen boost function.
So if your generator is what do you call that? It's not big enough. So for example, if the load is about 10 kilowatts and and it- and your generator is only 6 kilowatts. So what's hot? So when the generator is running and charging your battery and the load changes to 10 kilowatts, the if Phoebe is available, it will use the Phoebe first and then battery or both. So 6 from the generator and the rest is from the PV or the battery. So 4 kilowatts from the PV or the battery from the inverter. They will work together.
That makes sense. Thanks. It helps bridge the different load needs and requirements.
Yeah, yes.
Awesome. Thanks.
I just wanted to ask if I come up with questions later, after I go back to reread the presentation or even the install manual, or if go to actually be installing, because I haven't actually installed the 18K Luxes yet, but I've got several jobs coming up. But when I do have questions come up, what's the best way to get those answered?
So you can reach me at WhatsApp or my email.
Okay, is your email in the document, or I didn't see it?
On the chat.
Oh, it's in the chat box. Okay.
I think there's another question there, Gilbert, from Alpha Nova Solar in the chat box. When will they add an option to stop gen charge once started?
So, yeah, I believe they're working on that. They wanna, because right now they put the generator exercise, I believe, or I mean, yes, they're working on the stop gen charge. I'm not sure when it's gonna be available though. Any more question?
So now that the generator contacts are available, is there any plan to provide a monthly self-test for the generator? Maybe checking its voltage, make sure the frequency and voltage are stable, run it for 15 minutes and then shut it down monthly?
You mean generator exercise? I think it's available already.
Okay, I will look for it.
I haven't done much with generators yet with your systems, but how is if there's no stop generator charge, how is it triggered currently in the systems, just for my knowledge?
So if it's working with the 2-wire stop and start, it will use the generator stop setting.
So you can have the generator kick on when the batteries are at like 15% and then charge them up. Set certain parameters like that, right, Gilbert?
Yes, it's on the generator setting. So there's a charge start SOC. That's when it start the generator, and then the charge and as SOC. That's when it stop charging. And right now they put a cool down, so you can put minutes, 5 minutes, 10 minutes after it's charged the battery. It will turn off.
That's what he was
After
looking for, is like a time frame setting instead of just an
Yeah, it
instead of
should
like
be
an
on
SLC setting.
it should be under generator setting, but you must have 18 firmware and up.
No, that's fine. I was just trying to understand what he was actually asking about, or what feature it was he was looking at enabling, or problem he was trying to solve.
Okay. So can you see my window? So this is the cool down time. This is where you enable the generator boost. And this is the start and end.
Yeah, I got it. Thank you.
You're welcome.
That makes sense. Thank you.
Okay. Any more question?
Hey, can I ask another question that's not related to commissioning, but it's the functioning of the emergency stop?
Go ahead.
Yeah, so is my does the emergency stop button, if you connect one, does it shut the inverter down and eliminate the load output from it?
So yes, so it will shut down the PV input and the load output of the inverter.
And the load output inverter. Okay, that's what I wanted to make sure of, because the rapid shutdown device that I use, the Tigo, gets powered by a breaker that if it's in the critical load panel, it will initiate the rapid shutdown if the load output is cut. So that's so
Yes.
so it will cut the load output too, as well as the PV input both.
Yes.
Perfect.
So I think, hi, Gilbert, I think we got it end now.
Okay.
No questions. So any question in the future, feel free to call us. I'll just send a message to Gilbert directly. Okay. Thank you all.
Thank
Thank you, everyone. And sorry, this is my first time.
No, you're doing great.
Thank you.
Right. Okay. So we're gonna hang up here. Thank you all. Bye bye.
Thank you. Bye.